The main thing that distinguishes RoboSub is that the submarines in this competition must be fully autonomous.
The bots here are much more than ROVs. Each must navigate the course and complete the tasks without any student intervention.
Attaining true autonomy is the most challenging part of this competition.
For mobile platforms, the three building blocks of autonomy are navigation, perception, and intervention. Those are broad classes of behaviors that everything else depends on.
A big part of autonomy is determining when a task has actually been completed. For now, most teams' RoboSubs assume a task is completed based on visual cues and timing. Hopefully, this will become more sophisticated in the future.
So the robot knows if a task has completed or failed, mostly visual cues. So with the cameras, so let's say if we hit a buoy, if we see it moving still, or if we line it up orientation-wise for that buoy to be in the middle and we go a certain distance. So the biggest thing would just be testing to make sure that's right.
Our strategy for our autonomous code is basically we need to get to the waypoints that we set out in advance. Once we're close to where we think the competition element should be, we use the vision navigation control to identify key elements in the pool. Based on the different lighting conditions and geometric distortion, we correct for that in code. Then we set a new waypoint to drive to, controlling its orientation and position along the way.
Some teams incorporate a decision-making algorithm that prioritizes tasks automatically to maximize point scoring.
The robot stores a list of tasks and decides which one to do based on how long it would take to get to that task and how long the task itself takes, as well as how much points the task is worth.
In the beginning, in our very first year, we were just running based on doing everything sequentially, and then we moved on to incorporate the timers, the more decision-making part of things, and then now what we're actually doing is that since Dave put in the random pinger, now we actually need to know which obstacle we are at and then make decisions based on that too. So I think that every year we incorporate a certain part that adds on to the autonomous system.
One thing that makes underwater autonomy difficult is that you can't use GPS for navigation, because radio waves don't travel well through water.
A Doppler Velocity Log, or DVL, is a similar sensor that operates under the water acoustically, but it's much more expensive than a GPS receiver. Some teams have been able to afford one, while others have looked for alternatives.
Last year, we relied heavily on the Doppler Velocity Log in order to map where the points were. This year, it uses DVL to still get it close to the obstacle, but once it gets to the obstacle, it completely switches over to the camera system, and then it will continue with its normal mission for that obstacle.
We try and do the path less traveled and try to do all these tasks without a DVL, which is more challenging, but we are trying to come up with strategies using sonar, cameras, and IMU to get this done.
The goal of the competition is to prepare engineers for the difficult challenges of real-world autonomy.
Right now we have gliders that go out and measure the ocean current and temperature and give us the data that we need to feed our weather models. And they're out there for 6 months to a year, and they're only supervised once every day. So we're talking long periods of time where things change drastically from what they thought was going to be the conditions to what it is now.
We look forward to seeing new developments in autonomy next year at RoboSub's 20th anniversary.
Stay tuned at robonation.org.